Hello everyone, I hope all is well and that you've been able to enjoy the lovely weather we've been having and get outside even if it's just been on your front or back porch. So in today's video I'm going to be discussing section 12.2 and continuing with the surface area of a cylinder. So a cylinder is a solid with two congruent circular bases, and they are connected by a height, and the height is the perpendicular distance between those bases. So in a right cylinder, so this is a right cylinder, that height right there is going to be perpendicular to the base as we discussed in a right prism. So here I've got, this is base, this is a base, and then the lateral area is going to be what I call the soup can label. Alright, so if I were to unwrap the soup can, here is what I would actually see. A soup can label is a rectangle, so finding that lateral area is actually going to be not too difficult of a task. And then I am left with my circular bases here, and that's just as if you imagine you were undoing a soup can, peeling off the top. They're both circles, and they are congruent circles. So in order to find the total surface area, finding the area of one of those circles, all I'm going to need is the radius. So the area of this circle is going to be pi r squared. And the area of the other base is going to be the exact same. So that's pi r squared. And then I need to think about, I do have my height here. I have my height. I need to think about what is the length? What is the length around that soup can? What's the distance? And if I think about it, I wrap that back up. That's the same as the distance around its base, the distance around the circle. So what is the distance around a circle called? Circumference. So circumference is 2 pi r. So in order to find the area of that lateral surface, I need to have my length here. My base, length of my base here is 2 pi r times my height for the area of that rectangle. So if I were to write out the formula for my surface area here, so surface area, I have the area of my two bases, plus the perimeter around the base, which is called the circumference, times my height. Alright, and that should look really familiar to the formula for the surface area of a prism. The only difference here is that instead of a C, instead of circumference, since they're not circles, they're just any other polygon, they put P for perimeter. And writing this out more specifically, because you actually know formulas for the base, area of the base, and for circumference, I can fill in 2 times pi r squared for my base here, and then 2 pi r times h. Alright, so you can use those interchangeably. It's the same thing. It just depends on what sort of information that the problem gives you. Alright, so what you need in order to use this formula is your radius and your height. That's it. All you need is 2 pieces of information to go ahead and tippity type that into your calculator. So let's go ahead and look at example 3 in your textbook, which is on page 805. Alright, so I have a stack of CDs. It is a stack of 20 CDs, and they give me the radius, alright, and they give me the height of one CD. So the height of one CD is 1.2 millimeters, and the radius is going to be 60 millimeters. So R equals 60 millimeters. And they are asking, what is the minimum amount of shrink wrap needed to stack 20 discs? Now, I want you to keep in mind, I'm not trying to overcomplicate this problem. It's just 20 discs stacked on top of each other. So the only thing that really changes here is the height. All right, I just need to multiply that by 20 since I'm talking about 20 discs. All right, I do want you to keep this in mind for more complicated problems, though. Let me get out some manipulatives here. Alright, so let's go ahead and say I have two boxes. Alright, when I take the surface area of box 1 and the surface area of box 2 and then add the total surface area of the two boxes together, that's one thing. But then as soon as they say you're stacking the two boxes on top of each other, that's going to change it, because I'm removing some of these faces. When I stack this box 2 on top of box 1, I'm covering up that top surface here of box 1, and I am getting rid of the surface area of box 2 here when I stack them on top of each other. So that's not to overcomplicate this problem. This problem is just easily multiplying the height by 20 because I'm doing 20 discs. Alright, so I just want you to keep that concept in mind when you're tackling some of these word problems. Be very careful and read through it a couple times to understand what they're saying. Alright, so tackling this problem, I've got my formula here, which is 2 times my base plus circumference times my height, or 2 pi r squared plus 2 pi rh. Alright, so I am given the radius, and my radius is 60. 2 pi 60 squared plus 2 pi 60. And then my height, what I needed to compute for my height was the fact that it was 20 discs. So 20 times 1.2. 2 times 1.2 is 2.4. Move that decimal place. Alright, and that should be 24. So then I type all of that into my calculator, and I should get approximately 31,667 millimeters. Alright, now you can convert that, since it is in the metric system. It is millimeters squared. It is a surface area. You can convert that to centimeters or meters. It just depends on what you want to use, but that answer will do. Alright, that's only our first example, so please make sure to watch the next video and continue this lesson. If you guys have any questions, feel free to send me an email and ask. I miss you guys, and hopefully we'll see you soon.